And welcome back, Wolfpack. Welcome to today's lesson on parallel and perpendicular lines and their slopes. After today's lesson, hopefully you were able to find the slopes of parallel and perpendicular lines and solve problems regarding those slopes. Back in, I believe it's lesson 4.5, we've talked about parallel and perpendicular lines. If lines are parallel, they have the same slope. Okay? Same exact slope. And if lines are perpendicular, meaning they form 90-degree angles, when they intersect, sorry about that, hopefully you can see that, perpendicular lines, they have opposite reciprocal slopes. So you turn them upside down and change the sign. Okay? So, given the equation for y equals 5x minus 1, write an equation that is parallel and goes to the point -10, -4. We like to write our lines in y equals mx plus b form. So, in order to write the equation of the line, we need the m, the slope, we need the b, which is the y-intercept. We get to leave the y and the x alone. Well, since we need a line that's parallel to this line, we get to use the same slope. So we get to use the 5, okay? Now the only other thing I need is the b. Well, I don't have the b, but they did tell me that it crosses through or intersects this point. So if I use this as the x, and this is the y, and I already have the m, because the m is 5, I can plug all those in and find the b. So y equals mx plus b. Instead of y, I'm going to use the point -4 equals, instead of m, the 5, same slope, times x, -10, plus b, -4 equals -50, plus b, 46 equals b. So now I have my m, which is 5, and I have my b, which is 46, and my equation is y equals 5x plus 46. This is my answer. Y equals 5x plus 46. Again, your answer will have a y in it. It'll have an x. What you had to do was find the slope and find the y-intercept. Since our new line is parallel to our starting line, we use the same exact slope, which was 5, and then we used the point they gave us and plugged it in and found the b, the y-intercept, which is 46. The next one says it needs to be perpendicular to our starting line. So our original slope is 5. Perpendicular lines have an opposite reciprocal slope. So I need to turn, my original slope was 5, so m was 5 or 5 over 1. Opposite reciprocal means flip it upside down and change the sign. So 1 over 5, negative. So the slope I am now using and my new line will have is -1 over 5. Again, I'm going to plug in this point, plug in my new slope, and it'll give me the b. So y equals mx plus b. Instead of y, again, I'm going to use -4. For my slope, my new slope is -1 over 5. My x is -10 plus b. -4 equals, negative times negative is a positive. 1/5 of 10 is 2. Okay, so 10 over 5 reduces down to 2 plus b. Subtract 2 from both sides, -6 equals b. So rewriting, taking all this information and writing the equation of the line that's perpendicular to my original one, y equals my new slope, which is -1 over 5, x, and I need my new b, which is -6. Okay? So again, our starting line was y equals 5x minus 1. Our parallel line had the same slope, 5, and it had a new b, 46, because it had to go through that point, -10, 4. And our perpendicular line had a new slope, -1/5, which is the opposite reciprocal of 5. Slope criteria for parallel lines. Two lines are parallel. And let me go to a highlighter. Two non-vertical lines are parallel if and only if they have the same slope. So parallel lines have to have the same slope. Slope criteria for perpendicular lines. Two non-vertical lines are perpendicular if and only if the product, meaning you multiply the two numbers together, of their slopes is -1. Okay? -1. So, all vertical lines are parallel to each other, and all horizontal lines are parallel to each other. That should make sense, okay? Horizontal. All vertical lines, if they're running completely up and down, they are all parallel to each other. And the same thing for all vertical lines, left to right, okay? Completely horizontal, they are parallel to each other. Also, any vertical line with any horizontal line are perpendicular to each other. So any vertical line, here we go, with any horizontal line, here we go, are perpendicular to each other. So this vertical line with this horizontal line, they're perpendicular. They're going to form 90-degree angles. Okay, that's an explanation of those. Example number 2. I'm going to do those in class. So let's go to example 3. Example 3 says, find the coordinates of the missing vertex in each parallelogram. So PQRS has vertices of P -3, 0, Q -2, 4, and S at 2, 0. Find the location of point R. Well, I can see the point R is the third letter, so PQR has to be somewhere in this area before S. Okay? So a couple of ways that I can find this. I'm going to erase this so we're not confused. The slope of PQ, it's a parallelogram, so I can use the slopes. The slope of PQ is rise, 1, 2, 3, 4, over run. Okay? So the slope of PQ is 4 over 1. So if I start at S and do the same slope up 1, 2, 3, 4 over 1, here is point R. Okay, and I'm sorry, I know it's a little crooked. Okay, but the coordinate is at 3, 4. Okay, and I know it's a parallelogram because it says right here, parallelogram PQRS. Parallel lines have the same slope, so I found the slope of PQ, which was up 4 over 1, and found the slope of SR, which again was up 4 over 1, to give me my coordinates. Okay. You also could have very easily said, well, I can count 1, 2, 3, 4, 5. So count again, 1, 2, 3, 4, 5. Here's my new point, and found the coordinates that way. However, you will not always have a picture like this, and it will not always be on a nice straight line. So you cannot always bank on that. Okay. Letter B, so example 3B, I am going to do in class. So our last example is show that ABCD is a trapezoid. Oops, sorry about that, guys. Show that ABCD is a trapezoid. Computer's being silly. Okay. Well, what does a trapezoid have? A trapezoid has only one set of parallel lines. So looking at this picture, I think we can all clearly see that AB and DC look to be the parallel lines. DA and CB are obviously not parallel. So, how can I tell if two lines are parallel? Well, what do parallel lines have? They have the same slope. So let's find the slope of AB. Slope of AB is, starting here, is 1, 2. So rise of 2, 1, 2, 3, and a run of 3. So let's find the slope of DC. Slope of DC is a rise of 1, 2, 3, 4, and a run of 1, 2, 3, 4, 5, 6. Well, do they look to be the same? No. However, 4 6 can be reduced. 4 divided by 2 is 2. 6 divided by 2 is 3. 2/3, 2/3. So are these two lines parallel? Yes, they are parallel because they have the same slope. So you could say that AB and DC have the same slope. So they are parallel, resulting in a trapezoid. Okay, something along those lines. I know that it is a trapezoid because AB is parallel to DC. I know they're parallel because they have the same slope. And then finally, example 5 we will do in class. So as a recap, example 2, let's find that. Example 2 we will do in class. Example 3B we will do in class. And then example 5 we will do in class. Okay. Big things to remember. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Have a great day, Wolfpack. See you next class.